Chapter 4.2, Area. Day 1, Sigma Notation. Sigma notation is the adding of lots of different terms in a sequence. So, for example, in letter A, we have the summation of I from when I equals 1 until I equals 6. So what we're going to do is we're going to put all the integer values from 1 to 6 into that equation. We're going to get 6 different values, 1, 2, 3, 4, 5, and 6. And we're going to add them all up. So it looks like this. 1 plus 2 plus 3 plus 4 plus 5 plus 6. If we were to do that, we would add them all up and we would get 21. For B, we'll do the same thing. We'll sum the sequence I plus 1 from all the values of I equals 0 till I equals 5. So we would add up 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 plus 3 plus 4 plus 5 plus 6. All right, and we'd add those all up, and again, we would get 21. Now for a squared, we'd do the same thing. We would put in 3. We'd get 3 squared is 9. And we'd put in 4. We get 4 squared is 16. And we put in 5. And then we put in 6. And we put in 7. And we'd add all those up. 3 squared plus 4 squared plus 5 squared plus 6 squared is 7 squared. All right, same thing here. Plug in all the values from 1 until n. We'd plug in 2, we'd plug in 3, we'd plug in 4, we'd plug in 5, yada yada, we'd plug in n. And when it's function notation, you plug in all the values there as well. So basically, sigma notation, you're finding all the terms and you're adding them up. You're compiling, you're growing as you go. Some formulas that help us simplify these, because as you see here, A and B, quite easy to do in your head. 1 plus 2 plus 3 plus 4 plus 5 plus 6 is quite easy to get 21. All right? As you get larger numbers, it's not quite so easy. I probably could have done C, gotten a value. However, it would have been, I would have needed to break out the calculator. D, no, I can't do that in my head because there's too many numbers. There's n numbers. E, so many numbers. There's n numbers. So we need to simplify it down to a formula. And that's where these come in handy, the summation formulas. So formula number 1, the summation of a constant. There's not even an I there. We just got C, and we're adding it together n times. C plus C plus C plus C plus C, n times is C times n. All right. Number 2, the summation formula for when it's just I, from I equals 1 till n, it's n times n plus 1 over 2. Basically, you're going to take the first number plus the last number, multiply by the number of numbers, divide by 2. The first number being 1, the last number being n plus 1 times the number of numbers divided by 2. And then the same thing for a squared and a cube. Those formulas a little bit more in depth. All right? So let's look at these formulas and simplify some problems. All right? All right. So we got to evaluate the summation of I plus 1 over n squared from I equals 1 till n for n equals 10, n equals 100, n equals 1,000, and n equals 10,000. Well, first, let's use our summation formulas to rewrite that in a simpler way. All right? So we'll pop this up so we can see the summation formulas. First off, I equals 1 to n of I plus 1 over n squared. Let's pull out the n squared because in this problem, it's a constant. I is what changes. I changes from 1 to 2 to 3 to 4 to 5, but n is the same, no matter what. So I'm going to pull out 1 over n squared, and it'll be the summation from I equals 1 to n of I plus the summation of I equals 1 to n of 1. All right? The summation of I right here is n plus 1 over 2. So we'll have n times n plus 1 over 2 plus the summation of a constant is the constant times n. So this would be n right there. And it's just a matter of simplifying then. So we got 1 over n squared. And here we got n squared plus n, both over 2, plus, I'm going to rewrite that as a common denominator so I can simplify it later. So as we go through, we'll distribute. We'll have 1 over 2 plus 3n over 2 times 1 over n squared would be 3 over 2n. And as we plug in n equals 10, we get 1/2 plus 3 over 20. If we plug in n equals 100, we get 1/2 plus 3 over 200. And if we plug in n equals 1,000, we get 1/2 plus 3 over 2,000. And finally, we get 1/2 plus 3 over 20,000. And you can see each of those, the 1/2 is constant, but the fraction 3 over 2n gets closer and closer to 0 for larger values of n. Well, what is becoming of that is we're looking at letting n get larger and larger, let n approaches infinity. So we're adding an infinite amount of these terms and seeing what value we're approaching. Obviously, when you add an infinite amount of terms, there's a possibility it will grow without bounds. However, there's also a possibility it will level off. And that's what we're kind of getting to, is this leveling off. So let's look at this next one. Take the limit as n approaches infinity of 1 over n cubed times the quantity I minus 1 squared as we take it from I equals 1 till n. So what's going to happen here in purple, we're going to simplify this out. Let me first pull out the 1 over n cubed because that's not a variable in the sigma. It's a variable in the limit, but not in the sigma, so I can pull it out of the sigma. So limit as n approaches infinity of 1 over n cubed from I equals 1 to n, and I'm going to square that binomial. We'll get I squared minus 2i plus 1, and then we'll apply our summation formulas. The limit as n approaches infinity, 1 over n cubed. 4i squared, we got n times n plus 1 times 2n plus 1 all over 6 minus 2 times the summation for I, which is n times n plus 1 over 2 plus the summation for 1, which is n. All right? Now it's simply a matter of cleaning it up a bit. All right? I'm going to distribute n here, distribute n there. So we'll have the limit as n approaches infinity, 1 over n cubed. We'll have n squared plus n times 2n plus 1 over 6 minus, well, the 2's will cancel. So it will be n squared plus n plus n. All right, we'll distribute some more. We'll limit as n approaches infinity, 1 over n cubed. We'll FOIL the top. We got 2n cubed over 6 plus, first outside, n squared over 6 inside minus 2n squared plus 2n squared over 6. Last plus n over 6 minus n squared minus n plus n. All right, these will cancel because they're exact opposites. Let's go through, distribute our 1 over n cubed, and simplify as we do it. So the limit as n approaches infinity of 2/6 plus 1 over 6n plus 2 over 6n plus 1 over 6n squared minus 1 over n. Now, each of these, as n approaches infinity, anytime you got infinity on the bottom of the fraction, it approaches 0. So this will approach 0, this, and this. They'll all approach 0, and we're left with 2/3, or 2/6, which is 1/3. So the limit as n approaches infinity of that summation is 1/3. And we could not have done that infinite times, but using the formula allows us to see what it approaches. So in summary, sigma notation is the repeated addition of terms. It's an accumulation of terms. And that's what's important, is the sigma is an accumulation.